Hello, we are from ChemPraxis, and in today's video we will be covering Physics Paper 3, Variant 6, October-November 2022, Question 2. In this experiment, we will be investigating the properties of a transparent block. Before we proceed, let's look at the apparatus first. So these are the apparatus that are provided for us. As you can see, we have the meter ruler, the semicircular transparent block, and 2 sheets of paper with lines for our experiments later. Okay, so back to the question. Now we will need to take measurements to determine the radius of curvature r of the curved surface. So now, we will use the 30 cm ruler to measure the radius of the transparent block. Now this ruler is not provided for us, so I will recommend every student to buy one of these rulers so that it can be used for questions like these, or for your question 1 graph drawing. So to determine the radius, we will move the ruler along the horizontal line of the transparent block to the maximum point of the curvature, which we will get 4.5 cm. So now that we have taken our measurements, we will record the r as 4.5 cm. Always record to the 1 decimal point as we are using a ruler that can measure up to 1 mm. Alright, let's proceed on. Now, we are provided with a paper labeled P with 4 parallel lines drawn on it. A is the distance between the 2 central lines and B is the distance between the 2 outer lines, and we will need to measure and record them, which I have done using the 30 cm ruler as 1.1 and 2.5 cm. Then, we will need to calculate E, which is the ratio of B and A, which we get 2.3. For E, there will be no unit as the units of A and B would cancel off one another. Now, moving on, we will need to arrange the apparatus as shown in figure 2.2. As we can see, we will place the glass block horizontally across the lines of the paper, and we will need to look down from above with one eye closed, and we will see something similar to this. Then we will need to raise the block until the 2 central lines seen through the block are aligned with the 2 outer lines seen outside the block, like this image shown in figure 2.4. And we will move our head sideways to see the alignment. And with the block in that position, we will need to measure height d1, which is the distance between the block to the paper, like this image here. Alright, we can already see that this will be a problem to fix as the glass will not be in a stable position as our hands would move. So we can take note of that and write that down in our uncertainty and limitations later on. Take note that this is a 2 marks question, which implies that we will need to take at least 2 readings and find the average to get our D1. So here is our apparatus arranged, and following the instructions given, we will look directly from above and raise the glass block up to the point where we see the initial central lines move to align to the outer lines outside the glass block, and fix that position like this. So after that, we can measure the height of D1, which we will get 1.5 cm. So back to our question, we can now record our readings. I have repeated the experiment to get our second measurement, and now we can find the average of the 2 heights to get 1.75 cm. Then we can calculate the percentage uncertainty in D1. There are 2 ways to do this. We can use the half-range method, or we can use the absolute uncertainty of the measuring equipment, which is 2 to 5 mm. We will be using the half-range method this time as we have 2 readings, which we will get 14%. For the significant figures of a percentage uncertainty, we always follow the smallest significant figure of our substituted values. Now moving on to question B4, we will need to turn the block over and lower the curved surface onto the paper, and we will need to basically repeat what we did for the previous question and measure a new height of D2. So same thing here, we will place the blocks horizontally across the lines this time upside down and raise the block until the central line aligns with the outer lines outside the glass block like this. Then we will measure the height of D2, which we will get around 4.5 cm. So same thing, we will find the average of the 2 measurements to get our D2. And now moving on to question C, we will need to repeat experiments B1, B2, and B4, but this time with the paper labeled Q, which I have collected all the data here. Now, moving on to question D, it is suggested that the relationship between R, D1, and D2 is this equation, where K is a constant. Using our data, we will need to calculate two values of K. Now we will just rearrange the equation to make K as subject and substitute our values for both experiments to get 0.83 and 0.98. Take note that units are not a requirement for you to write for this question. Moving on to question E, it is suggested that the percentage uncertainty in the values of K is 5%. Using this uncertainty, explain whether our results support the relationship in D. So this is a very common question. We will need to calculate the percentage difference between our values of K and compare with the percentage uncertainty given. So this is the formula of the percentage difference which we will need to memorize. We will sub in our values, which we will get 17%, which is larger than the percentage uncertainty. Now we can write our conclusion. Remember, if your percentage difference is larger than your percentage uncertainty, then we do not support the relationship. If our percentage difference is smaller than our percentage uncertainty, then we support the relationship. Take note that it does not matter how large your percentage difference is, as long as it is larger than 0%. As long as you write the correct conclusions and calculations, you can get the full marks. So for this question, we can write, as the percentage difference is larger than the percentage uncertainty, hence, results do not support the relationship. If your percentage difference is smaller than the percentage uncertainty, you can write, as the percentage difference is smaller than the percentage uncertainty, hence the results support the relationship. Now moving on to question F, a property of the block called the focal length F is given by this equation. Using our results from C and our second value of K, calculate the value of F. So we just sub in our values and we will get 8.9. Now for our final question, which is finding 4 sources of uncertainty or limitations and their corresponding improvements. Always remember that all the uncertainties that you will need to identify are the ones that you will encounter when trying to take measurements. Now you may pause the video to think and write down the possible uncertainties and improvements for this experiment. Alright, now so for the first uncertainty and its improvements, you can always write this in any of your papers, so you will need to memorize this. You can write, 2 readings of K are not enough to draw a valid conclusion. And its improvement is, take more readings and plot a graph, or you can write, take more readings and compare K values. For the second uncertainty, you can write, difficult in measuring distance between central lines, as A is small, so uncertainty is large. Always identify what is hard to measure first and include a reason. If not, you will not be awarded with marks. And for the improvement, you can write, measure line spacing using calipers. You can always suggest a formula or directly draw a diagram to show how you will get a more accurate measurement if you do not know how to describe them. For the third limitation, you can say, difficult to judge alignment of lines. And its improvement, you can suggest, use thinner ruled lines. For the fourth limitation, you can write, hard to keep the block still in the correct position. And for the improvement, you can say, use the support of 2 adjustable stands or perform the experiment sideways so the paper is against the wall and the block lies on the bench, like the diagram right here. There's 2 additional uncertainties that we can write. The fifth one is, difficult to measure D1 and D2 as it is difficult to hold the ruler still, or ruler too long, or parallax error. And its improvement is, use a shorter ruler, or clamped ruler, or set square instead of the ruler, or use a thinner ruler. For the sixth uncertainty, we can write, difficult in measuring D2 as hard to judge the lowest point of the curve of the block. And for the improvement, we can write, measure to top of the block and subtract radius for D2, like the diagram right here. So this is the end of the question. If you like the video, don't forget to like, share, and hit that subscribe button. This is ChemPraxis, and thanks for watching.